Okay, Assalamualaikum and hi everyone. So in this video, we are going to continue our lesson in chapter 7, Ionic equilibrium. Okay, so for week 16, okay, we have chapter 7. Okay, and chapter 7 is consists of three parts: 7.1, 7.2, and 7.3. So basically for this video, we are going to discuss in for acids and bases for 7.1. So these are the learning outcomes for this topic. So at the end of this lesson, students should be able to, the first one, we are going to define acid and base according to Arrhenius, Bronsted-Lowry and Bronsted-Lowry theories. Then we are going to identify acid and base conjugate according to Bronsted-Lowry theory. And we are going to relate pH, POH to the ionic product of water, Kw at 25 degrees Celsius. And we are going to define strong acid and base, weak acid and base, pH, POH, and pKw. Okay, so these are our lecture overview for chapter 7.1. So the first one, we are going to define acid and base according to Arrhenius and Bronsted-Lowry. So for Bronsted-Lowry, we have conjugate acid-base pairs, and next we are going to identify the types of acid and bases, which is acid and bases can be divided into strong and weak, which is strong acid and strong base, then weak acid and weak base. And then we are going to discuss about pH, POH, pKw. Okay, and then salt, which is salt. We have three types of salt, which is neutral, acidic, and basic. And buffer solution. Buffer solution, we have acidic buffer solution and basic buffer solution. So acid and bases around us. So these are the example of acid and bases around us. So as you can see from here, okay, we have the lowest value of pH, which is 0. So these are the value of pH for car batteries. And then our stomach acid is pH 1. And then lemon juice is pH 2. Vinegar pH 3. Tomato juice pH 4. Then we have black coffee, okay, more acidic, slightly acidic, pH 5. Then milk, okay, milk actually is an acid. Then pure water, the pH is 7. Okay, so we have baking soda, toothpaste made of magnesia, household ammonia, soapy water, okay, and then oven cleaner and drain cleaner. So the drain cleaner is the most basic substance. Okay, all right. So definitions of acids and bases. So we can look into the definition of acid and bases. There are three main definitions for acids and bases, which is the first one is Arrhenius, okay, and second one is Bronsted-Lowry. So we have another definition of acid and base, which is Lewis. Okay, Lewis acid and base is not to be discussed in this lesson. Okay, so Arrhenius theory. According to Arrhenius, okay, mengikut Arrhenius, substance that produce H plus or H3O plus ion when dissociates in water or aqueous solution. Okay, so apa-apa saja yang menghasilkan H plus dan H3O plus. Okay, ion H plus dan H3O plus. Kalau dia dissociate in water. For example, we have HCl plus H2O liquid, okay, which is HCl, okay, hydrogen will dissociate, okay, with Cl, and then hydrogen will combine with H2O to produce H3O plus. So this is acid. Okay, HCl is an acid. Okay, next, Arrhenius theory. Okay, Arrhenius theory, according to for base, okay, it is a substance that produce OH minus in water or aqueous solution. For example, we have sodium hydroxide. So sodium hydroxide will release OH minus. So OH minus will combine with OH minus is the substance, okay, that is basic. Okay, Bronsted-Lowry theory. So for Bronsted-Lowry theory, okay, for acid is a substance that can donate, okay, yang akan menyumbang proton to another substance. Okay, so bahan yang boleh menyumbang proton kepada bahan yang lain. So this is according to Bronsted-Lowry. Okay, the example is HCl in water. So HCl will donate H plus. Okay, so when HCl donate H plus to H2O, so HCl is acid, and then H2O is base. Okay, in this definition. So according to Bronsted-Lowry, base is a substance that can accept proton from another substance. So just now, okay, we use the example of HCl. Okay, and then now NH3, okay, NH3 will accept hydrogen, okay, one hydrogen from H2O and produce NH4 plus. So NH4 plus is the conjugate for NH3. So NH3 is a base because it accept proton. Okay, so bahan yang menerima proton H plus daripada bahan yang lain. So conjugate acid-base pair. Okay, so the acid-base reaction can be written in the general form. Okay, so pasangan conjugate, conjugate is berselang-seli. Okay, so kita boleh tulis sebagai HA aqueous plus B aqueous produce A minus plus HB plus aqueous. So at our left hand side is HA. Okay, HA will donate the proton to B. So H and B combine produce HB plus. So bila HA donate proton, donate hydrogen, so it is acid. And then B, okay, B accept the proton, it is a base. So conjugate acid. Okay, conjugate acid is a species form when Bronsted base accept a proton. Okay, species yang terhasil bila Bronsted base menerima proton. And then conjugate base is a species form when Bronsted acid donate a proton. Okay, so species yang bila Bronsted acid menerima proton. So this is a conjugate. Conjugate means, conjugate adalah, conjugate sebenarnya dia berasal daripada conjugate base, dia berasal daripada acid. And then conjugate acid dia berasal daripada base. Okay, conjugate ni dia lawan, dia dekat sebelah kanan at our right hand side. Okay, so identify conjugate acid and base, conjugate acid and conjugate base according to Bronsted-Lowry Theory. So kalau di sebelah kiri, HCl is an acid, so HCl donate the proton, it becomes, this one is conjugate base. Okay, and then this one, bila dia terima proton, so this is conjugate acid. Sebelah sini dia jadi conjugate acid. Okay, alright. H2O becomes conjugate acid. Okay, so kalau yang di bawah, this one is base. Bila dia accept a proton from H2O, H2O is an acid. Jadi acid ni dia akan bagi H kepada NH3. So NH3 becomes NH4. So this is conjugate acid, and then this one is conjugate base. Okay, alright. Next, another example. Okay, HNO2. So HNO2. Okay, HNO2 donate is proton. So dia bagi hydrogen kepada H2O. So this one is acid. Okay, this is acid. This is water is a base. So bila water accept a proton from HNO2, so water akan menjadi conjugate acid, and then NO2 minus is conjugate base. NO2 minus is came from acid. Okay, alright. It is the pair of the acid. Okay, so note that the stronger the acid, the weaker is conjugate base. Okay, semakin kuat sesuatu acid, semakin lemah conjugate base. So the stronger the base, the weaker is conjugate acid. Okay, semakin kuat base itu, semakin lemah conjugate acid. Okay, so let us identify this. Okay, identify the conjugate acid-base pair for the following reaction. So this is an exercise. Okay, so it's very easy. Okay, you tengok di sini, NH2 minus, okay, NH2 minus, okay, and then becomes NH3, meaning that NH2 accept a proton. So dia adalah base, and then this one acid because it donate the proton to NH2 minus. So this one is conjugate base, and then this one is conjugate acid. Okay, so this one donate the proton, so this is acid. Okay, so donate one H plus to HCN, so this is base. Then NH3 becomes conjugate base. This one becomes conjugate acid. Okay, SClO4 will donate hydrogen, so this is acid, and then this is base. So this one is conjugate acid, and then this one is conjugate base. Okay, right. So types of acids and bases. Okay, jenis acid dan juga base. Okay, so it can be divided into two, strong dan juga weak. So for strong acid, okay, strong acid is acid that dissociate completely in water to produce high concentration of H plus and H3O plus. So it is 100% ionized, or alpha is equal to 1, and the example is HCl in water. HCl is a strong acid. Okay, so the non-reversible arrow, okay, arrow yang tidak berbalik ini menunjukkan it is a complete dissociation. So kalau dia complete dissociation, meaning that it is 100% dissociate. Kalau dia 100% dissociate, it is a strong acid. Okay. Alright, so strong base is a base that dissociates completely in water to produce high concentration of OH minus. So it is 100% ionized, or alpha is equal to 1. So these are the example. We have NaOH, okay, and then dissociate 100% to produce Na plus and OH minus. So NaOH is a strong base. So strong acids and strong bases, okay. Example of strong acid is HCl, HBr, Hi, HNO3, H2SO4, HCl4 minus, which is no oxygen, okay, hydrogen more than 2, okay. And then for strong base is a group 1 metal hydroxide, such as lithium hydroxide, sodium hydroxide, potassium hydroxide, okay. All is from group 1, and then metal group 2, okay, metal hydroxides such as calcium hydroxide, okay, strontium hydroxide and barium hydroxide. Okay, so unless told otherwise, we will assume that all acids and bases are weak. Okay, so weak acid. So just now we have already defined strong acid. Strong acid is completely dissociate. So weak acid is acid that dissociate partially in water to produce low concentration of H plus or H3O plus, which is the percentage ionization is less than 1, less than 100%, which is alpha is less than 1. The example is ethanoic acid. So ethanoic acid is a weak acid. So it is partially dissociate. Okay. And then it will produce CH3, COO minus and H3O plus. So the example of weak acid, hydrohalic acid, HF, acid in which hydrogen not bonded to oxygen or halogen, such as ACN and H2S. Oxo acids such as SClO, HNO2 and H3PO4. And organic acid, which is the general formula RCOOH, okay, methanoic acid and benzoic acid. Okay, so these are the graphical presentation of dissociation for strong and weak acid. Okay, as you can see from here, if the acid is strong, okay, kalau acid itu kuat, it is completely dissociate to produce high concentration of H3O plus and high concentration of A minus. But if the acid is a weak acid, okay, kalau yang di bawah ni weak acid, okay, after dissociation, H3O plus is partially dissociate. Sikit saja yang terhasil, and then HA masih lagi ada. Okay, so ini beza di antara difference between strong acid dengan weak acid. Alright, so for weak base, okay, base that are dissociate partially in water to produce low concentration of OH minus. The percentage dissociation is less than 100%, or alpha is less than 1. So these are the example. NH3 plus H2O produce NH4 plus and OH minus. So it shows a partial dissociation. Okay, dia menunjukkan separa. So these are the examples of weak acid, weak base. Example of weak base. Molecules with nitrogen that has a lone pair electrons. Okay, the example is ammonia. Okay, ammonia we have lone pair. Okay, because NH3 we got one lone pair here. Okay, alright, amines. Amines such as RNH2, R2NH, and R3N, such as CH3, CH2NH, okay, ethanamine, and etc. And then hydrazine, N2H4. So kalau nitrogen itu dia ada apa? Lone pair. Dia adalah example of weak acid. Okay, molecule with nitrogen yang mempunyai lone pair electron. Next, kita tengok pH, POH, and pKw. So, pH is the hydrogen ion concentration or concentration H plus in a solution, which is measured using pH scale. Okay, skala pH. So, pH is equal to negative log H plus. So, the pH is defined as the negative logarithm of the hydrogen ion H plus or H3O plus concentration. So this is the pH, the meaning of pH. Okay, if the concentration is high, okay, sekiranya concentration of H plus tinggi, the value of pH will be low. Okay, jadi nilai pH menjadi sangat rendah, which is dia sangat acidic. Okay, more acidic. Okay, next POH. Okay, POH is for base. Jadi kalau pH adalah untuk acid, POH is for base. Jadi concentration of OH minus is measure of using POH, which is POH is equal to negative log OH minus. So the POH is defined as the negative logarithm of the hydroxide ion. Okay, so you just use the calculator, just press negative and then you press log and then the value of OH. So if OH minus is high, POH is low and the pH value is high, meaning that it is more basic. Okay, because start from 0 and then 7 pH value, then this one is 14. Okay, so ini adalah nilai pH. So pH between 0 to 7 is acidic. Okay, pH equal to 7 to 14, okay, 8 to 14 is acidic. Meaning that, okay, di sini the value of pH is low and then this one POH. Okay, so this one is POH. Okay, so this one is POH is low. The value of POH is low. Sorry, the value of POH is high, then the value of POH is low here. Okay, so this one the value of POH dia akan increase ke bawah. Okay, dia terbalik dengan pH. Alright, next we discuss about ionic product of water, KW. Okay, so water molecules auto-ionize and transferring a proton from one water molecule to another, producing a hydroxonium and hydroxide ion. Okay, water molecule ni dia akan auto-ionize. Auto-ionize meaning that dia akan automatic terus bertukar mengion. And then water ionization equation. Okay, persamaan untuk water, H2O produce H3O plus and OH minus, which is KW kita sama dengan concentration H plus times concentration of OH minus. So KW is the product of water, ionic product of water at 25 degrees Celsius, which is in a pure water at 25 degrees Celsius. Concentration of H plus is equal to OH minus and value is 1 exponent negative 7 molar. So KW is equal to the concentration of H plus and OH minus. So 1 exponent negative 7 times 1 exponent negative 7 becomes 1 exponent negative 14. So 1 exponent negative 14, P pKw is equal to 14. Okay, so the relationship between pH, pOH to ionic product of water. Okay, apa hubungan di antara pH, pOH dan juga Kw? So Kw is equal to concentration H plus times concentration of OH minus, which is, okay, taking negative logarithm for both sides of equation, sebelah kiri dan juga kanan, so it becomes pKw equal to pH plus pOH, which is 14 is equal to pH plus pOH. Okay, at 25 degree Celsius, okay, the value of K is equal to 1 exponent negative 14. So negative log 1 exponent negative 14 equal to pH plus pOH, which is equal to 14 equal to pH and pOH. Okay, note that the value of Kw increases with temperature because the dissociation of water is an endothermic process. So for aqueous solution at 25 degrees Celsius, so acidic solution, okay, untuk acidic solution, concentration of H3O plus must be greater than concentration of OH minus. Yes, of course, this is because, okay, higher concentration of H plus leads to acidic solution. And then H3O plus is greater than 1 exponent negative 7 molar, and concentration of OH minus is less than 1 exponent negative 7. So for neutral solution, okay, untuk larutan yang neutral, okay, concentration of H3O plus equal to concentration of OH minus, which is equal to 1 exponent negative 7 molar. Okay, 1 exponent negative 7. Thus, okay, untuk basic solution, concentration of OH minus is greater than H3O plus, and OH minus is greater than 1 exponent negative 7. Consequently, the concentration of H3O plus must be less than 1 exponent negative 7 because dia adalah basic. Jadi kalau dia basic, it is low concentration in H3O plus and high concentration in OH minus. Jadi yang dominan di bahagian base adalah OH minus, dan yang dominan di bahagian acidic adalah H3O plus. Okay, so this is the pH scale. Okay, nilai pH, skala pH, which is the value of 0 to 7. Okay, 0 sehingga 7 adalah acidic, and then greater than 7 to 14 is a basic region. Jadi kalau di concentration di bahagian acidic, concentration H plus mesti lagi besar daripada OH minus, and concentration of H plus mesti rendah daripada OH minus untuk concentration pH yang basic. Okay, right. So bila concentration H plus tinggi, the value of pH will be low, and then bila concentration of OH minus is high, the value of pH will be high. Okay, jadi nilai pH tinggi lah. Kalau dia lebih daripada 7, dia adalah basic. Kalau less than 7, it is acidic. So the concentration of H plus is high, so the value of pH is low. Okay, so concentration of OH minus is low, pOH is high. So pH plus pOH is equal to 14. Jadi macam mana kita nak kira nilai pH? Okay, these are the slides that we are going to discuss about pH calculation. So in this topic, we are going to calculate the pH value of strong acid and base. So calculation of pH for strong acid. Determine the pH of 0.025 molar solution of hydrobromic acid. Jadi kita nak kira nilai pH bagi hydrobromic acid. Okay, so HBr plus H2O produce H3O plus and Br minus. So therefore, okay, since the symbol of arrow is non-reversible, meaning that it is a strong acid. Jadi kalau strong acid, okay, HBr dissociate will produce H3O plus 100%. So the concentration of HBr is 0.025 molar. Jadi concentration H2O plus pun 0.025 molar. So concentration of H plus is equal to 0.025 molar. We can calculate the pH. Okay, directly calculate the pH. pH is equal to negative log H plus equal to negative log 0.025, which is equal to 1.602. Okay, so now we calculate the pH untuk strong base. Okay, so for strong base, okay, pOH untuk CaOH2 is 0.1 molar, given 0.1 molar. So when CaOH dissociate, it will produce, okay, the concentration is 0.1 times 2, which is 0.2 molar. Okay, kenapa kita times 2? Because it produce 2 OH minus. Thus, pOH is equal to negative log OH minus. So, pOH is equal to negative log 0.2, which is pOH is equal to 0.7. Jadi, kalau untuk kira pH, okay, pH plus pOH is equal to 14. So, pH is equal to 14 minus 0.7, which is 13.3. Okay, which is, kalau 13.3 ni is basic. Okay, alright. Then calculation for weak acid and weak base to be discussed in tutorial. Okay, so that's all for our lecture today. Thank you, class.